So now we've worked through differentiation, let's go over integration. And we'll start off with the integration of inverse sine functions. Now, this integral formula here is actually given to you in your table. So it's actually less work than with differentiation because this is exactly as it is that's given to you. The only thing that you have to remember is that although this is what's given to you on your standard table, in your answers, you always have to write plus c, okay? So you always have to write plus c unless we're finding a definite integral, okay? So what I always like to do is on that table that you get, I always write a very big plus c on the top to remind me. Okay, let's go through questions now. So in question 22, I just want to find the integration of 1 on the square root of 1 minus x squared. So as soon as you see something that looks like this, right, you should be thinking about your inverse sine. So remember, this is a standard that's given to you. So all we really need to do in these questions is to find out what a equals to. So firstly, in exams, you need to recognize that this is going to be involved in this formula, okay? Because throughout this module, we know we're using this, but in exams, we don't always. And the second thing we need to do is find out what a equals to. Now, in this case, it's quite simple. You can see 1 is here, so a must equal to 1. So therefore, the integration of this is just going to be inverse sine x, and remember your plus c at the end, okay? So the plus c, remember, stands for the constant, and it's actually extremely important. It's not just like a little thing that you forget in your question. It shows, if you forget it, it shows to the examiner you don't actually understand the idea of finding the integration of something, yeah? All right, let's move on to the next question now. So in question 23 here, we want to find the integration of 1 on the square root of 4 minus x squared. So remember what I said, once you've recognized that this is what we're going to be using, the second step is to work out a. Now 4 is 2 squared, so a is going to equal what? Yeah, good, a is going to equal 2, isn't it? So if a equals to 2, I just substitute 2 in there. So I just have inverse sine x on 2 plus c, yeah? So it's quite a simple process here. All we're actually doing is really just working out what a equals to and remembering to always put plus c on the end. Okay, let's have a look at 24 now. So here, I want to find the integration, and this is 3 minus x squared. So not as easy as before, because it's not as easy to think about what a is going to be. But if you have a number like this, which cannot easily be square rooted, you can just make it square root 3, that whole thing's squared, yeah? So you can do that, and therefore a is going to equal to square root 3, yeah? Substitute that in, we get inverse sine x on square root 3, and then plus c. So this is just to show you that if you get a number like 11 or anything like that, you can just make it square root 3 or square root 11. Okay, so that was question 24. Here we have question 25 where we have a definite integral. So here, instead of differentiate, it tells us to evaluate because we actually want a final answer in terms of from 3 to 0. So let's firstly integrate that and work out what a is. Well, 9 is the same as 3 squared, so it's safe to conclude that a equals to 3 in this case. So the integration of that must be inverse sine x on 3, yeah? And it's from 3 to 0. So substitute in 3 first and then minus when it's inverse sine 0. And that essentially is just inverse sine of 1 minus inverse sine of 0, okay? And can you remember that inverse sine of 1 equal to, yeah, exactly, equals to pi on 2. Whereas the inverse sine of 0 just equals to 0. So that means that pi on 2 will be our final answer here. So just remember, and you can see I don't need to write plus c here, do I? Because the constant is only there when we don't have a definite integral, whereas here we only have one specific or definite answer. So yeah, that's why we don't need plus c here. All right, great. So this is working out your definite integrals, and remember, don't need plus c, But otherwise, with all of these things, you have to write plus c on the end of your answers.